Welcome everyone. Thank you so much for joining. The topic of today's webinar is Zero to Systems Engineering, and we want to get it done before lunch. Who will be speaking to you today? We are 3 speakers, and I'm very happy to introduce as our first speaker of the day, Marjolein, and she will be covering the organization and the people, and she is going to show you a very lean approach on how to check if your organization is already ready to make system engineering stick, or how to derive measures of how to do that. And then once you have that done, then there's a question of what do your people actually need to do? And how can we not overwhelm them? How can we not put too much on their heads? What's the minimum viable approach to get systems engineering up and running? And that's the research topic of Satya, our speaker number 2. And she will be telling you not all about it, a glimpse of it. And then the third speaker is already speaking to you. My name is Robert. I'm one of the founders of a company called Spicy Systems Engineering. And I get to talk to you today about how to get people into the tool. All the time we will try to monitor the chat. So if you have some questions, feel free to chat. There will be space for Q&A, so also feel free to unmute yourself and speak. That's also fine. And with that, let's get into it. So today, first, I would like to announce that we have 3 gifts for you. Now, the first gift is in this green gift box, and that is that 2 of the presenters are at the end of their respective academic how does one say that? Certifications. And they will both be available to the job market soon. And as you will see in the next minutes, they're really amazing at what they're doing. Little hint, it's not me who you can hire. They're really amazing at what they're doing, and offers will be coming in, so you better be fast if you want to hire them, make them an offer quick. That's gift number 1. Gift number 2. Satya will be talking to you today about minimum viable systems engineering. But since we are 3 in 1 hour, she's not going to have the time to explain it in depth, but she's going to take that time on 21st of September, 4:30 CAT. So pre-mark that, follow her on LinkedIn. We'll also be posting the link to this webinar in the chat. It already came in. So please sign up to that as well. It's going to be super, super interesting. And gift number 3. That's a gift from Marjolein and I. So we're going to talk a lot about the Zero to Systems Engineering part. And well, the first question is, am I ready? Is my organization ready? Is my team ready? And we are giving away 3 spots for a readiness assessment. You see the link here on the screen, but it will also be popping up in the chat as I speak. So feel free to apply here. And then we hopefully meet again one-on-one, and we'll talk about your organization and your team in more detail. And with that, enough of the introduction. And I would like to pass the torch to Marjolein to talk to us about how to get organizations ready. So I will unshare myself and mute myself as well. Marjolein, take it away.
Yes, let me share my screen. Thank you, Robert, for the introduction. So I'm currently finishing up my PhD. So over the last 4 years, I have been working on researching, understanding the forces shaping MBSE adoption. And I will quickly walk through the findings of my research. So it's going to be really condensed, but if you have any questions later on, feel free to contact me about it as well. Yes. So a little bit of a sneak preview of what I'm going to discuss today. So it's going to be about the journey from adoption confusion to clearer priorities. So most of you might be interested as an organization in adopting model-based systems engineering, or you might actually have already been working on it a little bit. But what I have seen and also seen in research is that a lot of organizations find adoption really challenging And if they are working on it, that it's sometimes actually might stagnate or that it's really fragmented throughout the organization. And to help with that, I set up this Marline magic, as Robert suggested to call it, in 2 surveys. The first one focusing on what shapes adoption in your organization, and the other one, how are these factors related? And with these 2 surveys, you then can do the force field diagnosis, making a lot of implicit perceptions from varying stakeholders explicit, creating a shared understanding. And with that, you can identify clear priorities on where to actually focus your change efforts. Throughout my presentation and this whole webinar, we're actually going to use an example of the office. I assume a lot of you might actually be familiar with this. It's a series about an office, so I'm going to also refer to some of the characters. So in this example, Michael at 9 o'clock on a Monday morning gathers everyone in the conference room, and he states that from now on, Dunder Mifflin is going to go model-based. But obviously, you will get different responses from that. If you're familiar with the series, then you know that Dwight is always in favor of anything Michael suggests. So he's super excited to start with model-based engineering. He already, on the other hand, is a lot more skeptical. So he just wonders what does this actual looking model. And finally, just really any he doesn't have time because projects.
Sorry to interrupt, Marjolein, if you can hear me, your connection is cutting out a bit.
Everyone. Sorry, I didn't hear that.
Your connection is cutting out a bit.
Is it getting better now?
It seems so. Maybe
okay.
You can start again on the middle picture of the last slide. I think that's when it cut out.
Okay, the middle picture. Yes. So Jim is always a bit more skeptical, so he's wondering what problem the model-based systems engineering is actually going to solve, and looks also critically at what Dwight already generated. Where Stanley is really against the change because he's already busy enough and he feels like he doesn't have time at all, also already leaving the meeting. So from these different perspectives and these examples, you can already see that there's actually a long list of barriers and enablers related to the adoption of model-based systems engineering. And this is also what I've seen within literature as well. Other 2 things that literature actually shows is that adoption is really organizational specific. So you can't just identify the most important barriers or enablers because it really depends on the situation within your organization. And finally, a lot of these factors are actually also interdependent. Think already about the tooling you use, which is often already linked to certain methodologies, and also influencing the training that you have to offer. So you can't just see them as separate from one another. So the research problem that I identified is that there is a missing dynamic context-specific picture of how all these barriers and enablers influence MBSE adoption. So to study that, I actually built upon field theory, and I will go over that quickly to give a bit of a good feeling for it. So field theory focuses on change, and it states that the current practice of your organization is influenced by driving forces and restraining forces with different strengths and different weightings, and that they always work in an equilibrium. So if you want to change your current practice, then you can't just adjust one force at a time, but you really have to take all of them into account, because reducing one might actually influence another one to become stronger. And field theory actually builds on quite three important characteristics. The first one is the analysis of a whole. So the behavior is a result from the complete configuration of forces. So you can't just identify single ones or important ones. You really have to look at them all at the same time. The second is that it is a subjective perception. So every individual within your organization might perceive these forces differently compared to others within the same team, but also between stakeholder groups. And finally, these forces are dynamically related. So they create this temporary equilibrium, but to really achieve a change, you have to see them linked to each other as well. So you can't just, what I earlier said, adjust one single one and assume that you're going to achieve the change you wish for, but you really have to look at them in relation to each other. So based on this field theory, I started the analysis of a whole. And based on that, I developed the force field of model-based systems engineering adoption. So this is a quick snapshot of all the forces that I found in literature, and I structured them in the whole force field. I'm not going to go into too much detail about it, but I will give you a few critical takeaways. So what does the force field teach us? It actually shows that it's multi-level. So a lot of these forces originate at different parts of your organizations. So you have an ecosystem level, for example, a team and an individual level. So you have various forces acting in different parts of your organization. The force field also evolves over time. So forces that might be really important in the beginning might be less important later on in the adoption process. And eventually, these forces are interdependent. So driving force clusters can actually drive adoption really well, while you can also have restraining force clusters, which create tensions and stagnate adoption. So this is the analysis as a whole, but then of course you want to move on also to the subjectivity and in identifying these interdependencies. So going back to the office example, where you have different perceptions that shape different responses. So then the next question, of course, is like, how do you make these different perceptions explicit, such that you know how the force field in your organization looks like? And that's what I did in my next research step. So I developed a diagnosis that turned fragmented perspectives into a shared picture. I call that the dynamic force field diagnosis approach, where I use two surveys. The first one assesses the force strengths of all these forces in your force field to identify the strongest forces within your organization. And then with a select group in survey 2, you do an interdependencies assessment to also create the insight, okay, if we have these strongest forces, how do they also link to each other? And based on that, then you can identify priority forces that you should adjust to achieve the biggest effect in your adoption process. And to give you a little bit of a better picture, I can show you what those outputs look like. So here we have the outputs of the first survey, where it identifies the top driving and restraining forces within your organization. So here on the left side, you get the highest rated driving forces, while on the right side, you get the highest rated restraining forces. And you also get the whole force field, where it sort of benchmarks the strength of all the forces. And
Marjolein, would you be so kind to zoom in a little bit? It was asked in the chat to zoom in just the slightest bit.
I can do that. I hope that works like that. So So here it gives you the overview where the strongest forces are highlighted, and the other ones are shaded to show as well the strength to a certain degree. But here you can use it as sort of a benchmark to see in which phase of the force field is your organization. So are you early in the adoption process or later on? And which forces are the most important, or at least strongest perceived in your organization. And then after the second survey, you move on to the second prioritization dashboard. I'll also zoom in a little bit again. And this one then results in the priorities. So here it rates the priorities, it links them, it tells you the force name, the priority, and the levels, and if it's a driving or a restraining force. And then in this lower graph, it actually shows the dots above are obviously the forces, and they are the influencing forces, which cause more influence on the other ones. The lower are the affected forces. So if you want to interpret that, that also says here, strengthen communication and knowledge management benefits MBC while increasing, decreasing limited awareness. So that's improved communication, improved knowledge management, and limited awareness. And if you address those forces, you will also indirectly impact the other ones. So this results in the priorities. Okay, then going back to my presentation. This approach I also applied within an organization, and what it taught us is that actually combining the strength and the interdependencies adds a lot of nuance. So the strength already achieves that it really creates a shared understanding of the forces within your organization, and the interdependencies add the nuance of how these forces are linked. And yes, Robert.
Sorry, I did not want to interrupt. There is a question in the chat, but we can do that after the slide.
Okay, yeah. Yeah, so these interdependencies add the nuance of how these are related, and also help them to give priorities to the forces to address. The second thing was that interpreter outputs are really, really important. So I have already updated the dashboards one more time to improve understandability of these results, because that also results, of course, in actual having benefits of using the method and ensures ease of use. And lastly, it actually supports the formulation of adoption strategies, because it gives a shared understanding of which forces to focus on for that time specifically. And based on that, then you can formulate adoption strategies that address these specific forces within your organization. So what does that mean in the end for Michael's situation, where Michael just announced that they were going to work model-based? They should have started with diagnosing the field. So they should ask the questions: who experiences this change? Who's going to work with model-based system engineering? What forces do they perceive? How do these forces interact? And where could we begin to start adopting model-based system engineering? So that's really short a summary of my research. So if you wish to know more, you can leave your email address to stay updated on future events and also research findings. If you want to have a in-depth chat about this as well, you can always contact me on LinkedIn or send me an email. And as Robert also mentioned earlier, I am available for work. So if you have any interesting job positions open, then feel free to contact me as well.
Thank you, Marjolein. And in the audience, we have Douglas. Douglas sounds maybe Dutch, who's already thinking in deep with you. And he's asking, in the force field diagram, why does the black line move up and to the right? Is that just showing that the green forces are winning, he asks?
Yes, yeah. So this is also based indeed on field theory. So how it is shown in field theory is indeed that that the line starts moving up once you start actually changing. So in these, I can go maybe back to the figure. Oh, wait. So that's also how I divided it. So in the unfreeze phase is kind of the preparation phase, where the move is really the implementation phase, and then the freeze is the institutionalization. So indeed, the line moves up because you kind of want to move closer towards model-based systems engineering adoption. So it kind of indicates getting closer to the new way of working.
Thank you very much. If you have more questions, we will do an overall Q&A at the end as well. Always feel free to put more questions. There's one already. Are there still regulatory bodies which are still misaligned for MBSD adoption, and can you give us an example?
Sorry, can you repeat the question?
Are there still regulatory bodies which are still misaligned for MBSE adoption?
That's a good question. I am currently not aware of that specifically, but I assume that there for sure are some, and that might also be industry specific or organization specific as well.
Okay, thank you. I was asked if the slides will be shared, not by default, but right to any of us, and we'll make sure that you get the slides. Also, the recording of this webinar will be put on YouTube as well, so you'll be able to rewatch it if it was exciting for you. Thank you very much, Marjolein.
Yes.
The really cool thing is force fields and many different impact factors, but she's found a really lean way to do the analysis. And again, apply for a one-on-one. And you can see it live. No, there's one last question. Leah asks, what is new compared to my thesis on the adoption of MBSE published in 2024, which was already based on force fields?
Yes. Leah, I actually read your thesis because I was already working on my PhD as well. So unfortunately, we have been working on some similarities as well. I think you have done really interesting research on that. I think the main difference for me, especially with that last part, is to make it really practical. So I developed that approach specifically, and I think that kind of builds on your work as well.
Right, thank you. Next question will be in the overall Q&A at the end. Yes. Thank you very much, Marjolein. And Satya is going to talk to you about methodology, more specifically the minimum viable systems engineering. I'll let you speak and share now.
So people, just give me a minute while I pull the slides. All good?
Yes, looks good.
Okay, great. Then let's get started. I am Satya. I'm a student at the University of Bremen who's almost about to graduate. I finished my exams, so just waiting for the certificate. And I will talk about the methodology. How can you get your team started with systems engineering? This is a very big word, MBSE, minimum viable systems engineering. But let's see how Dunder Mifflin applies this research. By now, you should understand that we are working on this entire webinar based on Dunder Mifflin. So, Dunder Mifflin Space GmbH, or the German company of Dunder Mifflin, has run its first space mission. They are supposed to build an orbital debris tracking satellite called DOTS. It is a 12U CubeSat that does some passive debris tracking in the circular SSO orbit in 24-month operational period, blah, blah, blah. So here's our amazing team. We have Michael Scott as the project manager, Jim Halpert as the lead systems engineer, Ham Beasley as the payload responsible, Oscar Martinez as mission analysis person, Dwight Schrute for risk and verification, Angela Martin as the PA, Kevin as OBC, and Stanley as the ground operation. If you're familiar with the web series, you would know how their personalities reflect with the characters I gave to their roles. If not, you should be able to figure it out by the end of this session. So, Michael has an idea how to solve dots. I bought the systems engineering handbook. You will read and get started with it. Well, that's with the kind of team composition we have, that's almost uncertain. And the Jim, the smart SE, says, how much SE, how much systems engineering do we actually need? And how do we make this entire team be using this approach? Doing the minimum. It's most often just enough. When you build a minimum viable product, it's lean, it does the job, and it gives you the freedom for improvement. If you apply the same techniques to systems engineering, it's called minimum viable systems engineering. It can just be described as the minimum of artifacts and the processes that will guarantee your mission success while you're avoiding some over major heads. MVSE comprises of 5 artifacts and a lot of other features, which I cannot completely explain you in 12 minutes. So come to my next webinar if you want to know more in detail. But MVR has 5 artifacts. The first one is MVR, the minimum viable requirements. These are the just minimum essential requirements per level. And the architecture baseline, which is the single source of truth, and dynamic interface matrix. It is the living matrix that is updated on a weekly basis. It is live. It is different from a ICD or a VCM that you might already have. Then risk-based verification planning. This is a quite new concept that you analyze the kind of verification you would do for a particular requirement, not by a random priority, but you prioritize it based on the kind of risk this particular requirement is associated with. Then you have decision capture log. How many of you have encountered situations that you forget why you took a particular decision? In order to keep the essence of that, the decision capture log is introduced. Now, the DOTS team is going to use MVSC in their project. And let's see how it progresses. So Michael comes up with his first requirement. DOTS shall detect space debris. That's it. And of course, Jim will ask all the right questions. All sizes, all orbits, in every condition. Is that even possible to determine everything based on that stupid requirement you give? It's very vague. It's unbounded. It's ambiguous. It's unverifiable. And it's not even mature. So it is rejected. Instead, you will write a requirement that is essential, testable, measurable, and it should directly be linked to the mission success. But what is the major difference between any good requirement and a minimum viable requirement? I would say it is the number of requirements you write. All of you, if you are from systems engineering background, you should definitely know that you write hundreds and thousands of requirements for a project. Instead of just writing requirements and requirements, if you think, how many requirements do we actually need? What is the minimum number? This comes from Miller's law, the cardinality principle. 7 plus or minus 2 is the minimum required number to write a requirement. So if you have 7 plus or minus 2 requirements, you can get your job done if you write them properly and you prioritize them in a good manner. So the requirement that Michael gave can be rewritten as something like, DOTS shall be designed to detect the orbits that are over a preliminary range of 50 to 500 kilometers with angular rates from so and so. Next, we have the architecture. Just having the functions of your system elements clearly drawn and connected is enough to understand how your mission works. If we look at the picture that I put up here, it starts with spotting the object, capturing the scene, knowing the spacecraft's position, detecting the candidate, then characterizing it, creating the detection report, and sending data to it. This is the function your satellite has to perform. Through these functions, you can derive what subsystems are there. So from this, you can say that you have OBC, you have communications, then you have optical payload. To power these, you will also have the rest of the satellite where you have power, where you have the parts. So every function we have here ripples to power budgets, mass budgets, data budgets, and etc. Then we have DIM, Dynamic Interface Matrix, which is a living matrix. It's not a static ICD. Even the simple payload to OBC, this one arrow will contain agreements about data, timing, commands, formats, ownerships, and lots of evidence. These agreements will change as the design progresses, with which if you have this clearly interlinked, you will also understand the impact, the ownership that is assigned, and the verification is well defined. This will become kind of like a single source of truth, which is being updated constantly, and you don't get lost in finding the latest version of the final V5 documents. Then, 6 months later, Michael asks, Pam, why did we take one decision? And it is because you said that this is how we do it. But is that how it is supposed to be? No. How often do you encounter such situations? I would say almost every day. Even I worked in a rocketry team. We would see these situations almost every day. We forget why we took a decision. That is why we should record our decisions, and that's what DCL is. So it is a log where you store all your decisions, your design decisions, your rationale, your trade-off, your alternatives, everything that is linked. And it ensures that everything is there and the future engineers and the members will know the reason behind the decision. Then we have Dwight. He wants to test everything twice. First, why not? If you're testing it twice, why not 10 times? But do we have the time for it? We could focus on something that is based on risk associated with. If you want to test something, you can go ahead. Yeah, Robert, I saw the question. We will answer it later. Of course, we will focus on what's wrong and how bad can this go. So if we prioritize it based on what is associated with it, the kind of risk that is associated with it. For example, if you're detecting a target and the detector is highly sensitive, it makes sense if you test it 3 to 4 times if required. But if it's just a telemetry packet, if you have to see it is working, if you just go for a low risk parameter by looking at it just through analysis or just through inspection should be enough to satisfy your verification. So maybe think of applying this in your projects. So traceability web, it is not a linear process, the thing I draw here. It is a network where decision capture log is sitting somewhere in between all of this. Every single element is in its own loop. So requirements flow to architecture, then architecture flows through DIM. DIM has something to do with verification. So everything is interconnected is what I'm trying to say. And during this entire process, you take your decision based on the risk associated with it. And it is how things get done in a much nicer manner. This is a small sneak peek of the spicy. I tried to implement this thoughts satellite on Spicy. Even though my methodology is tool agnostic, I try to implement the artifacts as you can see here. I'm sure Robert will explain more in detail. It's sad, but I cannot explain the entire framework in 12 minutes. So with minimum viable systems engineering, the teams can focus on engineering artifacts that actually matter the most. And you should not get lost in documents or something that does not add a lot of value, regardless of what domain you belong to, what product you're building, or which industry you come from. This is applicable. Yes, it's a space example, I know, because I'm a space engineering student. I came up with this. It's easier for me, but I'm sure it can be applicable to every domain. You just don't need one more process. You just need to understand what is the right amount of systems engineering for your particular project. So come to my next webinar, where I will make sure to talk everything about it for 45 minutes, and we can have a 15-minute Q&A. You can scan the QR, or I think Robert already dropped it in the chat. Then.
Yes, Satya, before you answer the question, I want to jump in and say a little thing.
Yes.
Two months ago, I had a smart moment because I was sitting in a talk about MVSE, and as you can see, it's implemented in Spicy, which is my tool. So after I heard Satya gave a talk and I was quite impressed with her methodology, I convinced her to work with us. That was a smart move. So now it's on you guys. She's now ready to move on from being our working student to building rocket ships and space stations and whatnot. So please be sure to make an offer quick, because it's going to happen very soon. And with that, Satya, I give back to you the first question, which is, how can we tell the difference between a decision and a requirement in this model? Do decisions become requirements?
Okay, the decisions become requirements. Maybe. It depends on the kind of decision you're taking at that particular moment. A decision could lead to anything. It could just be a documentation for future purpose, or it could be a critical aspect to change a lot of things in your design, or it could end up being a requirement.
Thank you. And then James asks, did you consider minimum viable artifacts or documentation in your research?
I did not get the question. It was all about minimum viable artifacts. So I have 5 artifacts which are associated with a few other aspects, like what are the gates you're trying to do, what is the process you're following, like it is mostly you should be following agile methodology, something like that. And documentation, I would say you only write it when it's absolutely necessary, but of course you're complied to regulatory bodies, and it's sometimes unavoidable, but you have to come up with a smart way of to manage your documentation and not make it a burden.
Thank you for the question, James. And then Frederick has a comment saying, if the end user is a public agency, V&V would have to be all-encompassing and exhaustive compared to the freedom that you gave your Dunder Mifflin company.
Yeah, I know. I totally get what you're trying to say. It depends again. If you're a young company, this was actually built for startups. That is where I started. So my master thesis was minimum viable systems engineering for rapid space systems development. So I was focusing on startups, and in their case, this is more than enough to get things worked. But if you're a fully established body and you're doing big projects, I don't think this is the case. But you can try to adopt this in situations where you can cut budgets, you can cut the time taken to manufacture something or time taken to test something. Maybe it's not applicable in every case, but it works. I heard a lot of things from my supervisors, my current company, and they find it very interesting.
Okay, and then looking at the time, I will take the liberty to answer the next two questions. So how did you get to that set of artifacts and what is being minimized? She's going to talk for a whole hour about this. If you're curious, go to her next webinar. Also, the next questions, looking at the time, I'm sorry, great that you're so curious. Please make sure to contact Satya, sign up to her next hour-long webinar and discuss with her in super detail as well. Thank you very much, Satya. And also we'll have an overall Q&A session, hopefully, if I don't blab on for too long. So I am going to re-share my screen. So is it showing? Yes, here it comes. So we've heard about organizations from Marginline. We've heard about organizations and the different people and the roles and their heads from Satya as well. And I do want to look at an organization again. And first, I have a confession to make. I have absolutely no idea about the office at all. But I love the idea because they're so famous. I know all the memes, but I have actually no idea who's who and what their characteristics are. So please excuse me. But looking at their organization, I get a thumbs down. What a bad way to enter into my talk. But if you look into this organization, we see there's many different people, many different characteristics, backgrounds, academic, social, and whatnot. But we can also see many different tools being used, right? They have good ideas. Their brains have a lot of output. Where do they put it? They put it in emails, Teams, Excels, PDFs, wikis, Confluences. I'm sure you know this from your organization. So how can we clean this up? What can we do? Well, the first thing is, let's sort it into a left and a right side. We have to transition two different sides to a systems engineering model. So on the left, we talked about them as the different people, their perspectives, their knowledges, and how do we get them into a systems engineering model? And if we're talking about systems engineering model, it's not going to be on the whiteboard of your office, right? It's going to be digital. So it is going to be in a tool. It's going to be digitally supported somehow. So how do we get your people from where they are and what they're using now to using a comprehensive system engineering model without them complaining to you about it? And then the second question is, well, we have all this data. Our people thought long and hard for years to get all this data out. How can we put it into the model? Isn't that going to be month and month of rework and we don't have the time, we don't have the money? Well, let's look at the two sides of this. By first looking at people. This is Dwight, I know this. And if we look into Dwight's head, it looks a bit triangular shaped. Why is it triangular shaped? Well, he has a lot of what I want to call common skills, right? How to write an email, make a PowerPoint presentation, tie your shoes in the morning, all that stuff, right? These are common skills. This is what we all share. But this is not what we hire people for, right? Why do we pay our engineers a ton of money? It's because they have some very specialized and specific skills that we need from them, that we hire them for. And ideally, in your organization, you have a lot of different skill sets. You have a lot of people who are very, 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 very capable in their domains. They might be simulation experts or electrical E&E experts or testing experts, or whatever they're experts in, but they are experts. That's what you pay them for. And it's very important to realize that you want them to stay these experts, right? You want their heads to be able to be at the top of the pyramids for as much time as possible, because that's what you're actually paying them for. So now I ask the question, looking at this mountain range of brains, where would you make a connection here? Where's the obvious point to make a connection? It's right here. If we want to connect our people, it's in their common skills, it's in the skill set that they all share. Where is it not? It's not here, right? The distances are too far apart. I will never understand what a fluid dynamics expert does. I have no idea. It's too crazy for me. I hated it in university. And the The problem that most companies running system engineering suffer today, I feel, is they just built another mountain. They have a guidebook, they have their own language, they have their own very high peak, and then they stand on top of it, and then they hope that everyone comes over. They will not. It's an impossible task. We need to connect people at their common skill. Oh, I get a heart. I've equalized the thumb down. So let's look at two people, and let's look at what's on their mind. How can my company, my department, and my boss succeed? Why? Why systems engineering? What's in it for me? Now, one of these is a thought that someone actually has, and one of it is a thought that I kind of made up. Can you guess which it is? Well, you didn't want it that way, but it is. This is what we say, this is what we pretend in meetings and year-end reviews to get more salary, to get the next position, right? It's what our intelligent brain knows we need to do and care about. But it's not what our heart wants. It's not what our heart wants. Our heart that got us through years and years and years, 6.5 for me, of engineering school. It's the other side. It's the question, what is in it for me? Sounds maybe a bit self-centered, but it's the truth. It's human nature. So what does that mean? How can I convince my people to come to me in a systems engineering model, system engineering environment? It's all about return on invest. And not from the company, not a milestone standpoint, nothing like that. The question is, for me as a person, for me as a discipline expert, as the super awesome in my field that I am, what's in it for me if you introduce systems engineering to me? Let's talk about the invest first and the criticism. It's like, I know what I'm doing. I've built rockets before you were even born, right? We all know these sentences. Why are you telling me to do something different? Leave me my tools. Don't take them away from me. I've handled them for years and years, and I'm really good at it. And I don't have time. You came to me with a tool yesterday. You came to me with another tool 2 days ago. I don't want to anymore. I do not have time for you, right? We've all heard, if you have ever tried to introduce system engineering to a new organization, you've heard some variation of these points. But what's the return? What's the return? And now don't say, well, our project will hit the milestone 3 days earlier and blah, 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 blah. That's the academic brain talking. It's not going to catch their hearts, right? Less meetings, less friction, and less rework. What do I mean by that? If I start working on something on a wrong assumption, and I have to do it again because like, oh, the customer, didn't you hear last Christmas? They told us they now want the rocket to fly 5 kilometers higher. No, I didn't hear about it. And too bad, now redo everything. We've all been in this situation. And so it all boils down for passionate engineers that I'm hoping for you hired in your organization. They want to focus on their topic. They want to focus on whatever they were interested in that brought them to where they are. And if you can prove that system engineering will do that for them, then they will follow you. If they have the feeling that systems engineering is going to take their brain away from their topic and more to your topic, which is system engineering, they're not going to like that all that much. So how are we going to do that? Looking at time, I might skip a bit that I have, but I want you to see Satya's model that she was kind enough to build with us to show you how we make that possible in Spicy. Well, number one, you can see it looks good, right? It looks sweet. And this is already very important because you don't want to go into something that doesn't look nice, doesn't feel nice. And what you can also see here, if you've ever been into a full-blown super system engineering solution, not that many buttons, not so much to learn here. And what you can hopefully also see is that something that looks requirements-ish on the right and something that looks architecture-ish on the left, why should you make your people learn multiple tools for that? And I'm just going to go super quick through this. Stakeholder needs, not yet minimum viable requirements. They might not be perfectly formulated just yet. We collect them and we derive our context architecture down here on the left. Super, super important because we know what's in and what's out. We're delivering the dots, the thing in the middle, and we're not developing, we don't have influence over the outside. Really good to have that picture harmonized in the heads of your organization. And then if you select a system boundary, you will see all of the requirements relevant to the system boundary. Which brings me to the two main points of why a tool sticks, right? You can think about why my grandma has WhatsApp now. because it's exactly that point. If I go into level down, I'm going to open up this black box into white box and see a component architecture. Okay, so now imagine your triangle is this box here. You are responsible to build this thing. What do you need to learn? What's your invest? You need to learn the level up, level down button. Go find your box and click your box. You can do that. And then what do you have? You have exactly the pieces of information that you're looking for. Right? This is why one of the things why my grandma uses WhatsApp, because she gets pictures of her grandchildren. And that made her want to learn it, because the information is very specific to her needs here. Same goes for this. We see all our interfaces going in and out. We see all of our requirements that are relevant to us building. We see our linkage, a little sweet linkage tree up here. Review status, all kinds of things that I'm going to gloss over. What's the second part that makes a tool stick? It's feedback loops. If I don't get feedback, I, in a previous life, had a role as a system architect. I architected a nice model and then no one complained about it. Why? Because no one knew how to even open it or look at it. That's very sad, right? It makes you want to jump straight to email, which is also why my grandma uses WhatsApp, because she gets a direct response there. We love feedback loops. So if you can make it so that you have, for everyone on your team, no matter their head triangle, specific information, and when they make a change, they get feedback on it, then is a tool going to stick. And because I do want to go into a bit of a Q&A session, I'm going to just swiftly touch on the second topic that I promised, which is the data topic. So now we know how to get our people involved, specificity of information and feedback loops. And now the question is, oh, but we've built all this data and we've used it and everyone knows where it is and where to find it. No, that's not true, you're lying. How do we get all the data that is already there into the systems engineering model? You have two options. Number one, you do it manually, but who has the time? It's going to take you forever, you'll make mistakes, and so on. Or you're going to use an AI agent like Spicy's own Pepper, which I would have loved to show you, but I have to do it like Satya, and I'm announcing now that there will be a follow-up webinar on Pepper as well, because I'm just running out of time. The important thing here is you need the AI to be smart enough to understand what's going on, but to be cautious enough to always ask you for permission and always ask you for review. But this has now become a teaser. I'm going to show you this in a follow-up webinar. So with that, all that's left for me, yeah, you would have seen how this whiteboard sketch would be imported, but again, teaser, we'll do that next time. Again, a reminder, go to this link, spicese.com/0 system engineering, and apply for a one-on-one assessment. Thank you very much to my two co-presenters and to everyone who is here and was here. And I'll open the floor for the last 5 minutes of questions. Sorry for being so rushed at the end here. I saw a hand up. Don't be afraid, it was taken down again. Any questions? Put in the chat. Yusuf, please, can you unmute yourself and speak? Yes, right? You have permission. Okay, Yusuf, if you can hear me.
Yeah.
There you are.
Yeah, can you hear me?
Yes, I can hear you well.
Okay, great. First of all, thank you all for this session. It was very insightful. And maybe my question or my comment about maybe I'm coming from software development, and I don't know if you hear about the C4 model by Simon Brown.
Yes.
Maybe I see a lot of similarities between when you mentioned about the system context or the context level, the first one, and then we go deeper to the container, and then go deeper to the component, and then code level. And based on the level of the audience, we share the knowledge and communicate and see the dependencies with each layer and with the other system and so on. So I see a lot of similarities here. between. Was very interesting. But maybe this is the first time I see a software like Spicy have this in a tool. So then maybe I will try to test it and review it a little bit more. But this is the comment I would share, and I would suggest anyone just to read about the C4 model. I think this is very relative to the system engineering as well.
If I can build upon that, in systems engineering, if you went down the system engineering rabbit hole, which I think many people in this room have, your brain is like, okay, here I am with all of my knowledge, and at the top of my mountain, I'm a system engineering mountain. I would like to twist that on its head, and I would like, maybe some of you have sons who have built something in Lego before, and then they came and they showed it to you. What did they do? They imagined, oh, I need a secret treasure chest in my spaceship that I'm going to build of Legos, right? So they made a requirements analysis. They designed it. And then they went to their mom or their dad and they're like, look, look, look. And did they find the treasure or not? Right? That's their test case that they performed. So this concept of a V model, of what do we want to build, how are we testing it, it's ingrained in us. It's very natural to us. So I would turn it around. I would start with the little kid building Legos, and then see, talking about minimum viability, how far do we need to push it to make it viable for real products, instead of taking what we have, the deep methodology frameworks and such, and then reducing them down. And I think C4 is nice enough because it's at the bottom of that. But I feel it could still be a bit leaner as well. All right, in the chat, I read, thanks. Great, thank you all for participating. We have time for maybe one more question before we close on time. Feel free to speak up, feel free to write in the chat. All right, it seems all questions were answered then. Thank you all for participating. You know where to go. You know what the next webinars and things to do are. Thank you to my wonderful co-presenters, and see you at the next one. Yeah, we're going to wait for all the applause to come in. It's nice. And then we're going to close. See you in the next webinar.
Thank you. Bye-bye.